All right, the last section in 8.5 is about angles of elevation and depression. Okay, so the thing to keep in mind is that these angles are always created from a horizontal line of sight. Okay, that's very, very important. So an angle of elevation is formed from a horizontal line of sight. So if you were standing and looking and your line of sight was parallel with the ground, and that's going to be those objects that are above a horizontal line of sight. Okay, so in angles of elevation, your right triangles generally will look like this. Okay. An angle of depression, again, you've got that horizontal line of sight, and those objects are below that horizontal line of sight. Okay, so your right triangles will look something like this. Here, there's your angle of depression because the objects are below the horizontal line of sight. Okay. So some examples. It says Leah wants to see a castle in an amusement park. She sees the top of the 190-foot castle when she looks up at an angle of elevation of 38 degrees. If Leah is 5.5 feet tall, how far away is she from the castle? Okay, so first things first. Our angle of elevation, so from that horizontal line of sight looking up at the tower, is 38 degrees. Okay, here, to find that vertical height, since it's specified that she's 5.5 feet tall, we're going to take that 5.5 feet away from the 190 to get 184.5 feet, and we are wanting to know how far away from the castle she is. Okay, now here we are going to label, that's our right angle, so this will be our hypotenuse. Okay, here's our angle. Across the triangle is the opposite. Right next to it, from the angle's vertex to the right angle, that's the adjacent side. Since we've got something opposite and we're looking for the adjacent, tangent uses opposite and adjacent. So the tangent of 38 is the opposite over adjacent. If we treat that like a proportion, we can cross multiply. We get x times the tangent of 38 equals 184.5. And then we divide both sides by the tangent of 38. Okay. And at this point, you can type that directly into your calculator. Okay, 184.5 divided by the tangent of 38 tells me that Leah is about 236 feet away from this castle that she's looking at. Okay. All right. Example number 2 says the crossbar of a goalpost is 10 feet high. Okay, so here picture the field goal bars. Okay, that bottom we know is 10 feet high. Okay, field goal attempt is made 25 yards out from the base of the post. Okay, now this is a little, we've got to pay attention to our units here because 25 yards is the same as 75 feet. Okay, so here, right angle, that helps form your right triangle. Okay, and we actually want the ball to clear the goal by 1 foot. Okay, so we're actually going to go, instead of 10 feet, we want 11 feet. Okay, it says what is the smallest angle of elevation at which the ball could have been kicked? Okay, so our vertical distance here, remember, is 11. That is opposite our angle. Okay, this 25 yards or 75 feet. Opposite here. That is our adjacent side. Okay, here's our hypotenuse, but nothing is attached to it, so it's not important. Again, we've got opposite and adjacent, so that tells us we're going to use tangent. And tangent of some angle is going to be 11 over 75. But remember, when we're looking for an angle, the measure of that angle is going to be the inverse function that we choose with that ratio of sides being what is put into the parentheses. So the tangent inverse of 11 over 75 is 8.34 degrees, or about 8 degrees if you'd like. Okay, example number 3 here. Search and rescue team is airlifting people from the scene of a boating accident when they see another person in need of help. The angle of depression to the other person is 42 degrees. So here's our horizontal line of sight, like we're in a helicopter. And when we look down, this angle created, that is your angle of depression. And we know that that is 42 degrees. Okay, the helicopter is maybe 18 feet above the water. And then it asks, what is the horizontal distance? So we are looking for that distance there. All right. Let's go ahead and label our sides in relation to this angle. Okay, from the vertex to the right angle, that is always our adjacent side. And then here we travel across the triangle. 18 is your opposite. So again, opposite and adjacent is tangent. So tangent of our angle, this time we know the angle, is opposite over adjacent. Okay, treat this like a proportion. X times the tangent of 42 is equal to 18. Divide both sides by the tangent of 42. And we get 19.99, or about 20 feet away. Horizontal, that's the horizontal distance. Okay, now keep in mind that we can create a rectangle, and this here is going to be the same as this here. So we could look at that triangle there. Either way, though, we're going to get that search and rescue team's about 20 feet away. Okay, this one is very similar to the previous one. We have a lifeguard watching from a line of sight that is 6 feet above ground. Okay, that angle of depression is 8 degrees right here. How far away from the tower is the swimmer? So this horizontal distance here is what we're looking for, but that horizontal distance is also represented by that horizontal distance. Okay, so we label in relation to this angle here. Okay, 6 feet is opposite. Surprise, surprise. X is adjacent. And again, tangent of our angle is the side opposite over the side adjacent. Treat this like a proportion and cross multiply. We get x times the tangent of 8 is 6. And now we divide, maybe, both sides by the tangent of 8. And rounded to the nearest foot, we get 43 feet.